Okay, welcome to Chapter 8. This is one we're going to talk about variation. There's going to be three types that we talk about. It's going to be direct, joint, and inverse variation. So when we have direct variation, that means it says y varies directly as x. So that means as y increases, so does x. Now, what we're going to talk about is that there's a k, what's called the constant of variation. So if we're told that y is 27 when x is 6, we want to be able to find that constant of variation and then the k value. And so we just put it in, y equals k times x. And so to find k, we're going to take 27, put the 27 in for y and the 6 in for x in this case, divide by 6, so k is 4.5. Well, y is equal to 4.5x then. So whatever your x value is, if you multiply that by 4.5, that'll be your y value because it's going to go up proportionally as we go. So if we were to graph that, it's a linear function. You go to your calculator if you wanted to. You could definitely do that and then graph it and see what it looks like there. Okay. Now, as we kind of talked about this, is that we have some other cases here, but what you can kind of get out of this then is that if you're solving a direct variation problem, is that, well, you can kind of tell that k is then found by taking the y divided by the x. So if you set up that proportion with the different things, you can be able to solve for the one that's missing. Let me show you a case here that we have. So the cost of an item in euros varies directly as the cost of dollars. Okay, euros and dollars. As the cost goes up for euros, so it does for dollars. So it's direct. So 3.85 euros is the equivalent of $5. So find the dollars when you have 10 euros. So here's what you can do. It's direct variation. You can set up the cross multiplying the proportions here. So you can just say, well, 3.85 euros is to $5 as 10 euros is to D dollars. And then, of course, we have to cross multiply. So 5 times 10 is 50. If we take that 50 and then we divide that by 3.85, that should give us the number of dollars that 10 euros would be. So we would say it would be about $12. And we'd round that to maybe 99 cents is what we would do there. Okay, so just a little crisscross applesauce, cross multiplying. That's what we do to solve and set up the direct variation. All right, so let's talk about joint variation. Now, joint variation is just like direct variation, except there's a couple of variables that are involved. So now instead of just y equals k times x, there's another variable involved with that. And an example of that might be looking at the volume of a cone. So the volume gets bigger as the area of the base gets bigger, and also if the height gets bigger. So there's two things affecting that. So there's still a constant of variation, a k. So we're going to write this in as the volume is equal to k times the area of the base, that's what the big B represents, times the height. So it tells us here that the volume is 12 pi when B is 9 pi and H is 4. So what we can do is we can put those values in, and we end up getting, in this case, you'd have, let's say I should probably put intermediate step, 12 pi is equal to 36 pi is what that is, times k. So if you divide those, it's basically 12 pi divided by 36 pi. The pi is chunga chunga. 12 divided by 36, of course, is 1/3. So that's what k is. So we're going to put that back into our formula. So V, the volume, is going to be 1/3 the area of the base times height, which actually is the volume of a cone. All right, so now it says find B. So now we don't know the area of the base. When the volume is 24 pi, we still have the 1/3. We don't know what the area of the base is, but we know the height is 9. Well, so in this case, we would take 1/3 of 9. So we would have 24 pi is going to be equal to 3 pi. Let's see. Well, actually, just 3. Sorry, not a pi. 3 times b. I'm sorry. So then to find b, we just divide by 3. So the area of the base, which is a circle, if we divide that by 3, is going to be 8 pi. So you can use joint variation. That's kind of the trickier one because you have a couple variables operating on that. All right, and then another one that we have is inverse variation. That's when one gets bigger, the other gets smaller. So the faster you go, the less time it takes to get there if the distance is constant. So we would say that y is equal to k divided by x. That's what we have there. So if we say y varies inversely as x, y is 4 and x is 5, let's find the function. Well, again, put 4 in for y, 5 in for x. So we would multiply by 5, so k is 20. So y is going to be 20 divided by x. So if we know what x is, to find y, just take 20 divided by that x. That's what we get. All right, so with that, All right, with that, we can kind of conclude that, well, then to find k, you basically are finding y times x each case. So we're going to use this as a way when it says inverse variation to solve. All right, so here it is. So let's talk about this. Let's see, I'm going to do this one. I like the worker problem. That's what I like to do here. So if 20 volunteers can build a house in 62.5 hours, how many working hours would it take? 15 volunteers. So we know there's less volunteers. It should take more hours. So to set this up, we're going to set up products. 20 volunteers times 62 and a half hours. That gives you the total number of hours that you have. So that should be the same as 15 workers. We don't know how many hours that's going to be. So what we're going to do is take 20, we're going to multiply that by 67.5. All right, we get that. That's 1350, and then we're just going to divide that by 15. And by no surprise, it takes us longer. Actually, it's going to take us 90 hours is what it's going to do with less workers, and that's it. So that's how you set up inverse variation as you do those. And again, put those in your notes, and everything should work out very well. So again, 3 types of variation. We have direct, joint, and inverse variation. All right.